And we are back in video mode with video 3.1. We are starting with an introduction to inequalities. Most of you have seen them before, know what to do with them. We're just going to get a quick introduction, so we'll be ready to do more advanced things in the following lessons. So some vocab that you need to get down is, what is an inequality? It's a mathematical sentence that compares two expressions, and they are shown by these inequality symbols here. You should get this chart in your notes as well as these definitions and the examples that are in purple. So x is greater than 4. That's what this sign means right here. The value of x, whatever it is, should be greater than 4. So it could be 4.5, 5, 7, 1,000. But it can't be anything lower than 4. So it can't be 3.9999999. It must be greater than 4. Now a compound inequality may be new. It's a combination of two or more inequalities. So how we read this is y is greater than or equal to -3 because the greater than symbol is pointing towards the y, and less than 6. Y is greater than or equal to -3 and less than 6. So we're going to work a little bit with these in this lesson so you can get more comfortable with them. So first, another definition you need to get down is a solution set. And what a solution set is, it's the set of all values that make an inequality true. So inequalities and equations differ in the fact that in equations, there's only one value, usually, that makes the equation true. In inequalities, there's a range of values that can make the inequality true. So instead of one solution, we have what's called a solution set. So in order to determine what values are part of the solution set, we can plug them in and see if the inequality is true. So I have this inequality right here of 3 plus x is less than or equal to 1. So I'm just going to substitute each of these values for x and see if it makes the inequality true. So 3 plus -3 is 0, and 0 is less than or equal to positive 1. So that's true. Now we're going to plug in -2. And 3 plus -2 is 1. Now 1 is less than or equal to 1. 1 is equal to 1, so yes, this checks out. And now we'll plug in 0. That equals 3 is less than or equal to 1. That is not true. So that would be a no. And then we'll plug in 2. And 5 is not less than or equal to 1. So that is another no. So that's just plugging in and testing out if the inequality is true or not. We can see these solutions more easily by graphing inequalities on a number line. We're going to graph them on coordinate planes later in the week. But for now, we're just going to graph them on number lines. This is very important to get in your notes, however, that the sign depends on what type of circle you'll put on the number line. So if it's or equal to, it's a closed circle. That means that the number is included in solution. And if it's not or equal to, if it's just less than or greater than, it's an open circle because that number is not included in the solution. So all you do, we have our inequality right here. X is greater than -4. I'm going to put an open circle because it's just greater than on -4. And then I'm going to shade everything that is greater than, because that's what this sign says, -4. And if your inequality is set up with the variable on the left-hand side, you can usually just shade in the direction of the arrow. So if it's pointing towards -4 here, you see right here it's pointing that way, I'm just going to shade that way. And that's all you do for graphing inequalities on a number line. Now I mentioned before compound inequalities. So with compound inequalities, it's a little trickier, but you're just graphing both inequalities on a number line. So I have this first one right here, -1 is less than x, and x is less than or equal to 7. So x is greater than -1, but less than or equal to 7. So I'm going to put my circles first. So I'll put an open circle at -1 and a closed circle because it's or equal to a positive 7. And x is less than or equal to 7, but greater than or equal to -1. So that means I'm shading every everything in between, everything that is less than 7 but greater than -1. With our second example here, we have y is less than or equal to 0 but greater than 5. So I need to put my circles first. So I'm going to put a closed circle on 0 and an open circle on 5. I'm going to shade everything less than 0 and greater than 5. And that is how we graph compound inequalities on a number line. So for your hot question, this is a regions question. I want you to put the letter of the answer that you're choosing in the hot question document and then explain your reasoning for choosing that answer. So which of the following is not a solution to the inequality y is less than or equal to -1? Which of the following is not a solution to that inequality shown?